When installing a nipple between a flush-mounted panel board and a surface-mounted panel board, several solutions exist. One approach involves cutting an access hole in the drywall. Firstly, measure and mark the location of the nipple. Secondly, cut a rectangular access hole around the marked area using a drywall saw. Thirdly, install the nipple using appropriate connectors and sealing compound. Finally, patch and paint the drywall hole. Another method utilizes a threaded pipe extension. Firstly, attach a short threaded pipe extension to the nipple on the flush-mounted panel board. Secondly, screw the surface-mounted panel board onto the extended nipple. Thirdly, seal the connection with electrical tape or compound. A third solution involves installing an enclosure. Firstly, mount an electrical enclosure, for example, a junction box behind the drywall. Secondly, connect the nipple to the enclosure. Thirdly, connect the surface-mounted panel board to the nipple through the enclosure. The additional charge for flush mounting a subpanel or transfer switch can vary depending on several factors. These include the size and complexity of the installation, the materials and labor required, and regional pricing rates. Typically, a charge of $150 to $300 is reasonable for this type of service. It is important to ensure that the nipple size is appropriate for the current carrying capacity of the feeder cables. Use a nipple with a length that aligns the surface-mounted panel board with the flush-mounted panel board. Label the nipples and connectors clearly to avoid confusion in the future. Consider installing waterproof connectors if the installation is exposed to moisture. Understanding electrical concepts is crucial for safely working with panel boards and nipples. Let's delve into some essential aspects. Electrical current flows through conductors, and the size of the conductor, or in this case the nipple and associated wiring, must be adequate to handle the amperage. The National Electrical Code, or NEC, provides guidelines for determining the appropriate conductor size based on the ampacity, which is the current carrying capacity of a conductor. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to trip or open the circuit when the current exceeds a predetermined level. This prevents damage to equipment and reduces the risk of electrical fires. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping the overcurrent protection device. This helps to prevent electrical shock hazards. Grounding systems typically involve connecting metal enclosures, equipment, and conductive parts to a grounding electrode, such as a ground rod or metal water pipe. Bonding involves connecting different metal parts together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electrical shock. Bonding is often required for metal conduits, enclosures, and equipment grounding conductors. Conduit is a protective raceway used to enclose and protect electrical wiring. Different types of conduit are available, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of conduit depends on the application and the environmental conditions. Connectors are used to join conduit to enclosures, boxes, and other fittings. Different types of connectors are available, such as threaded connectors, compression connectors, and set screw connectors. The choice of connector depends on the type of conduit and the application. Electrical boxes are used to house electrical connections, such as splices, terminations, and devices. Different types of electrical boxes are available, such as metal boxes, non-metallic boxes, and weatherproof boxes. The choice of electrical box depends on the application and the environmental conditions. When working with panel boards, it's important to follow proper lockout/tagout procedures to ensure that the power is turned off before working on any electrical components. This involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent accidental re-energization. When making electrical connections, it's important to use proper wiring techniques to ensure that the connections are secure and reliable. This includes stripping the insulation from the wires, twisting the wires together, and using appropriate connectors such as wire nuts or crimp connectors. When installing panel boards, it's important to follow the manufacturer's instructions and all applicable electrical codes. This includes ensuring that the panel board is properly sized for the load, that the wiring is properly installed, and that the panel board is properly grounded. When working with electricity, it's important to be aware of the hazards involved and to take appropriate safety precautions. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. Working with panel boards and electrical systems requires a thorough understanding of electrical theory, safety practices, and applicable codes. If you are not comfortable working with electricity, it is best to consult with a qualified electrician. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years and provides detailed requirements for all aspects of electrical work. It's essential to consult the NEC to ensure that your electrical installations comply with the latest safety standards. Understanding voltage drop is crucial for ensuring that electrical equipment receives the proper voltage. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for calculating voltage drop and for selecting conductors that are large enough to minimize voltage drop. Short circuit current is the current that flows during a short circuit. Short circuit current can be very high and can cause significant damage to equipment. It's important to calculate the available short circuit current and to select overcurrent protection devices that are capable of interrupting the short circuit current. Ground fault protection is designed to detect ground faults and to trap the overcurrent protection device. Ground faults occur when current flows from a hot conductor to ground. Ground fault protection is required for certain types of electrical equipment, such as those used in wet locations. Arc fault circuit interrupters, or SIs, are designed to detect arc faults and to trip the overcurrent protection device. Arc faults are dangerous electrical arcs that can cause fires. SIs are required for certain circuits in dwelling units, such as branch circuits that supply bedrooms. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning, power outages, or other electrical disturbances. SPD divert the surge current to ground, protecting the equipment from damage. Harmonics are distortions in the electrical waveform that can cause problems with electrical equipment. Harmonics can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonic filters can be used to reduce the levels of harmonics in the electrical system. Power factor is a measure of how efficiently electrical power is being used. A low power factor can cause increased energy consumption and can reduce the capacity of the electrical system. Power factor correction capacitors can be used to improve the power factor. Electrical safety audits are conducted to identify potential electrical hazards and to ensure that electrical systems are in compliance with applicable codes. Electrical safety audits can help to prevent accidents and to improve the overall safety of the electrical system. Infrared thermography is a technique used to detect hot spots in electrical equipment. Hot spots can indicate problems with connections, insulation, or other components. Infrared thermography can be used to identify potential problems before they lead to equipment failure. Ultrasonic testing is a technique used to detect defects in electrical equipment. Ultrasonic testing can be used to inspect insulators, bushings, and other components. Insulation resistance testing, also known as a mega test, is used to measure the resistance of insulation. This test can help to identify insulation that is deteriorating or damaged. A low insulation resistance reading indicates that the insulation is compromised and needs to be replaced. Transformer oil testing is used to assess the condition of the oil in transformers. The oil provides insulation and cooling for the transformer windings. Oil testing could detect contaminants, moisture, and other problems that can lead to transformer failure. Circuit breaker testing is used to verify that circuit breakers are operating properly. Circuit breaker testing includes testing the trip time, the contact resistance, and the insulation resistance. Grounding system testing is used to verify that the grounding system is properly installed and functioning correctly. Grounding system testing includes measuring the ground resistance and verifying the continuity of the grounding conductors. Electrical system coordination studies are conducted to ensure that overcurrent protection devices are properly coordinated. This means that the overcurrent protection devices should trip in a coordinated manner to minimize the extent of the outage in the event of a fault. Selective coordination is a type of coordination that ensures that only the overcurrent protection device closest to the fault trips. This minimizes the disruption to the electrical system and prevents unnecessary outages. Arc flash studies are conducted to assess the potential hazards of arc flash events. Arc flash events are dangerous electrical explosions that can cause serious injury or death. Arc flash studies are used to determine the required personal protective equipment, or PPE, and to develop safe work practices. Power quality monitoring is used to identify and diagnose power quality problems. Power quality problems can include voltage sags, voltage swells, harmonics, and transients. Power quality monitoring can help to improve the reliability and efficiency of the electrical system. Energy audits are conducted to identify opportunities to save energy. Energy audits can include analyzing energy consumption data, inspecting equipment, and identifying areas where energy can be used more efficiently. Load calculations are used to determine the electrical load requirements for a building or facility. Load calculations are used to size the electrical service, the panelboards, and the branch circuits. The NEC provides detailed requirements for load calculations. Demand factors are used to reduce the calculated load based on the assumption that not all electrical equipment will be operating at the same time. Demand factors are specified in the NEC. Diversity factors are similar to demand factors and are used to reduce the calculated load for multiple dwelling units. Service entrance conductors are the conductors that connect the utilities electrical system to the building's electrical system. The size of the service entrance conductors is determined by the load calculation. Overcurrent protection for the service entrance conductors is provided by a main circuit breaker or fuses. Panelboards are used to distribute electrical power to branch circuits. Panelboards contain circuit breakers or fuses that protect the branch circuits from overloads and short circuits. Branch circuits are the circuits that supply power to individual loads such as lighting, receptacles, and appliances. Branch circuits are protected by circuit breakers or fuses in the panelboard. Receptacles are used to provide a convenient means of connecting electrical equipment to the electrical system. Receptacles are typically rated for 15 amps or 20 amps. Ground fault circuit interrupter, or GFCI, receptacles are required in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electrical shock by detecting ground faults and tripping the receptacle. Lighting fixtures are used to provide illumination. Lighting fixtures are available in a variety of types, including incandescent, fluorescent, and light-emitting diode, or LUD. LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. Electrical boxes are used to enclose and protect electrical connections. The electrical boxes are available in a variety of sizes and shapes. Conduit is used to protect electrical wiring. Conduit is available in a variety of materials, including metal and plastic. Wire connectors are used to join electrical wires together. Wire connectors are available in a variety of types, including wire nuts and crimp connectors. Electrical tape is used to insulate electrical connections. Electrical tape is available in a variety of colors. Cable ties are used to bundle electrical wires together. Cable ties are available in a variety of sizes and materials. Labeling is used to identify electrical components. Labeling is important for safety and for troubleshooting. Electrical drawings are used to document the electrical system. Electrical drawings typically include single-line diagrams, panel schedules, and wiring diagrams. Single-line diagrams show the electrical system in a simplified form. Panel schedules list the circuit breakers and the loads connected to each circuit breaker. Wiring diagrams show the wiring connections for the electrical system. Electrical permits are required for most electrical work. Electrical permits ensure that the electrical work is performed in accordance with the electrical code. Electrical inspections are conducted to verify that the electrical work is performed in accordance with the electrical code.